Good evening and welcome to our next talk. We've got someone special tonight with us, Svenja Schröder, and she claims to know who I clicked last summer. She's been using mathematical graph theories to find that out, looking at all the social communities where we can link our friends and share our experiences. And now let's not see who I clicked last summer. Enjoy.
Test? Okay. So hi, my name is Svenja. I'm a bit excited that so many people are attending this talk. And I'm a bit nervous, but okay, I think it will work. So my talk is about social network analysis. And okay, I start. So here's the table of contents. First, I give you a short introduction, then I will explain some basics of network analysis and social network analysis. And then I will show you some measures you can calculate on social networks, and I will show some general network measures and some actor measures. So then I will show some algorithms you need to calculate something at social network analysis, and then I will briefly show you what you can do by enhancing this whole thing by using an ontology. And then I will show a bit of an example which is not already finished, but I will get onto this later. So I think I have very many slides. I will go through all this, and at the end you are able to ask some questions. So introduction. What is social network analysis? It's an interdisciplinary approach. It combines concepts of sociology, formal mathematics, and statistics. And it's a bit mashup of all those things. And the basic idea is to model actors and their relations, for example, interactions between persons, into an interpretable model. And this whole thing is a very precise method for defining social concepts. Application fields. It's, I don't know how many of you are in a Web 2.0 community. It's like maybe StudiVZ, the German Facebook. You can see who's the friend of your friends, and you know above how many other people you are connected to a person the profile you're visiting, and you always see a bit like you always see a special part of this network, which is of your network and your reach in this network. But if you, for example, pass all those data from one community, you have this whole concept and this whole network, and then you can even guess more structure and more. You get the whole picture from this network, and then I will just go on, and maybe this will get clearer later. So, application fields. Social network analysis is used in sociology, geography, social psychology, communication studies, and so on. So, there are very many application fields for this, and it's for the analysis of all kinds of social structures. And for example, this might be communities of actors, or groups and subgroups, or even associations, societies, and states. And a popular example I was already showing to you is social software, which has become very popular the last years, and Web 2.0 communities, as I mentioned. A very popular example is the small world experiment from Stanley Milgram, who examined the average path length of social networks, in his case of the US. And he did several experiments in the 70s, which were, he randomly sent packets to US citizens, and picked randomly another US citizen to who this packet should go to. And then he sent little postcards with this packet and said, okay, please send this package to this other person. Maybe you don't know this person, but yeah, if you don't know this person, please send the package to another person of who you think could know the target person. And yeah, and so all the persons on the way the packet went had to send a postcard to Stanley Milgram so he could guess where the packet was in the US. And the conclusion of this experiment was that in average there are six persons. Yeah, there's an average path length of 6 persons, which led to the 6 degrees of separation myth, which says that in a small world network, or even some people even said in every network, that there are only 6 degrees between every randomly picked actors in this network. Okay, let's come to the basics. Yeah, what does a social network look like? That's very easy, because a social network is a graph. And so, yeah, many concepts of social network analysis are based on network or graph theory, but the point is to get the right interpretation. So, yeah, social structures are modeled as a graph. And this graph consists, of course, of a set of nodes and a set of edges. And yeah, the edges are the most important part of this network because, yeah, this is what all is about. Not the actors are not examined separately, but the whole network as a whole is examined with all its structures and links and ties. And so the attributes of a single actor or part of this network is not this important, because the edges are the most important thing of a network. Yeah, something about node and edges. Nodes, of course, represent the actors or elements in this network, which in a social network are actors. And sometimes you can add node weights, like a small number expressing some attribute like, yeah, nose length or stuff, I don't know, which you can add to this node, but this is very uncommon because, as I said, the relations or the edges are the most important part of a network. So the edges represent the relationships between the actors, and they can differ in content, weighting, and form. Content means they can represent different relationships, like, yeah, communication, like phone calls or Java messages, transactions, like who is sending a package to whom, or every other social relationship you can imagine. Then weighting also means that you can weight an edge, which means you add a small number which is indicating the intensity of the edge, which means, like, for example, if you count phone calls, you could add to this edge the number of phone calls, which, of course, if you call a person 5 times, would be more intense than if you only called a person 1 time. So the form is very important. An edge can be directed or undirected. So normally you indicate this with the directed edge with a little arrow to the node it is pointing. That means an edge has a direction or hasn't a direction. So, yeah. There are different types of networks. Yeah, the type of network you choose depends on the network you want to examine. Because if you, for example, have friendships in a social community, like, not MySpace. If you have mutual friendships, like you ask someone for his friendship and the other person has to accept this friendship, then it's kind of mutual friendship, on which both persons have to agree. Then you maybe could take an undirected edge because the friendship hasn't got a specific direction. But if you maybe have something like, not mutual friendships, like you only add friends and the person doesn't have to agree. So then you could add directed edges, which count a bit like a kind of vote. You vote somebody. Yeah, that also is important for network flow, because if you have directed edges, you couldn't go in the wrong direction. So that's kind of simple, because if you have like an arrow, you couldn't go in the wrong direction of the arrow. Yeah, a one-mode network is a network with only one type of nodes. So if I would model you as a social network, it would be a one-mode network, because I would only model human beings. But if I would maybe model like who is attending which talk, so I would maybe take you as actors and then the talks as a second type of node. This is, okay, I'll just go on. So, as what I described is also bipartite or affiliation network. It's a two-mode network with a set of actors and a set of affiliation. And affiliation means it's a kind of something you can attend or have, or I don't know. So in this network, there is, it says which persons are connected to which affiliations. So if I would take all those talks of this Congress as affiliations, I could model which person is attending which talks. Ego-centered networks are a special kind of social networks, which those are networks from the view of a specific actor. It's like if in social sciences, if you make an interview and ask who is friend of yours, you could model an ego-centered network, because in the center there's the interviewed person, and then around this person there are the friendships of the of friends or whatever of this person. Yeah, there are some common network representations, as you maybe know from graph theory. It's of course the matrix. It's the classical mathematical way, but most of the time, if you have to compute a large matrix, you get very many memory problems. Because if you have 400 actors, it's 400. It's a lot of a lot to compute. And there's the adjacency list. Is this right? Okay. So you only store the neighbor or follower nodes for every node in a linked list. So you just leave the empty fields in the matrix out. Okay, not really, but kind of. So this is a very more compact representation of a network, but it's better to compute and less memory intense. And there's of course the graphical visualization, which is for you, for example, easy to grasp and intuitionally comprehensible, because you can see in a network who is linked with whom, and you don't have to scroll through a large matrix to guess who is linked with whom. But okay, it also has some limitations, because if you imagine you have a network with 500 people, it's then it's not even intuitionally to grasp, because it's too big. Yeah, something about paths in a network. As I mentioned, no, I didn't mention that before. I'm sorry. There are not only direct connections, like an edge, an actor, an edge, and an actor. That would be a direct connection, but also indirect connections, which means he is a friend of a friend of a friend, and then you get path length, which are bigger than one. So a path is a kind of walk between two nodes without visiting a node twice. It's a nice metaphor, I think, to walk between little nodes in the network. So edge directions are also important in a directed network. It's like, okay, you cannot walk in the wrong direction, so you have to walk the right direction of the arrow. There's a measure called geodesic or distance. It's only the shortest path between two nodes. So if you say, okay, there's node A and node B, I have 3 paths, okay, one is 5 edges and one is 4 edges, one is 3 edges. Okay, I'm lazy, I take the one with 3 edges. And that's the distance, or geodesic. Yeah, if you want to interpret this all, for social network analysis, a path describes a flow of information and resources. So yeah, it's, as you can imagine, a path of 4 or 3 edges or 7 edges, the one with 3, the information is faster and is not distorted as much as on the way with 7 edges. Yeah, because long path length can lead to distortion of information. It's, yeah, there's just distortion, maybe, depends on the social network topic. Yeah, I'm going to show you some network measures. And due to the limited time of this talk, I picked out some. If I will, show you my resources later. So if you're interested in getting more about other measures, I will get you. You can look this up in the resources I tell you later. So it's just I picked out some of the easy measures. Yeah, one is the density. It's a graph measure. It measures connectivity in the network on how many links are in this network, and it's just the number of edges which are in this graph divided by the number of possible edges. It's a very easy measure, and of course the subject of the network has influence on the density because friendship networks tend to be more intense, like say co-worker networks. And with this measure, for example, you can compare different networks on a very basic way. So the next measure is called degree. It's an actor measure. It's a measure for single nodes in this network. It's also very basic, as I told you. It's it describes kind of influence of the actor. And in an undirected network, the degree is the number of edges which touch the node. So if you count all edges, that's it. That's the degree. You can normalize it by dividing by all edges possible to other actors, but it's your choice. And in a directed network, there are 2 kinds of degree, because you have directed edges or 2 kinds of edges, like incoming and outgoing. And then there's the in degree, which is the number of incoming edges, and the out degree, which is the number of outgoing edges, which you can interpret in other differently, because incoming edges are always kind of vote. Somebody votes you, and outgoing is kind of you vote for somebody. That's an example. It could mean maybe any other things you can imagine. Depends on the topic you're examining. There are 2 measures which are called centrality and prestige, which are very nearby. They are mean kind of same things for undirected and directed networks, and they describe importance, visibility, and prominence of single actors in this network. It's also an actor measure, and as they indicate prominence in this network, a prominent actor has bigger influence. So it's you model kind of influence people have on other persons in this network. I'm going to start with centrality. I'm going to get this very brief. So if you want to look up all the mathematical stuff, maybe you turn on Google and Google it, or you ask me. So this measure measures involvement of actors, the involvement of actor in connections of other actors, and the centrality works on undirected networks. And there are 3 types of centrality. It's just different ways to compute the centrality. Depends on what exactly you want to know And there's degree centrality, closeness centrality, and betweenness centrality. And I'm going to explain betweenness centrality later in a bit more detail. And yeah, the others I'm going to explain now. Degree centrality is only the degree of a node. That's very, very, very easy. So you just take the degree of a node and you have a kind of centrality measure. And closeness centrality is, yeah, if nodes only have short distances to other nodes. So maybe if you look at all those paths to all other nodes in the network, then a one with only short paths to other networks or short distances, I mean the shortest paths, have a bigger centrality than those with only long distances. Yeah. Most of the time, those centrality measures are known to network size, which means that you only divide by the number of maximum paths or stuff or edges, depends on your measure. Yeah. Betweenness centrality is used most frequently. So this one measures the number of shortest paths going through the actor. That means a person with a big betweenness centrality sits on very many distances of between other actors. It's I'm always thinking of the spider web metaphor, but that's not really right. Maybe it's it's not right. But it's if you have a high betweenness centrality, then you're very central person. Okay, so the equation shows that G is for all geodesics, all the distances, and I explained that. Okay, I'm just going on. Prestige is not the same, but very, it's for a directed network and indicates how many direct or indirect votes an actor receives. That means you only have a look at the incoming edges or incoming relations, also with the path length longer than 1. And there are different types of prestige, like, for example, in-degree prestige or proximity prestige. I'm not going to show you this in detail, but I can explain you this now briefly. The in-degree prestige is, if you can guess, the in-degree of a node, which is very easy. You just count the number of incoming edges. And proximity prestige is, if you are voted or if you're reachable by very many actors on a short path or a short distance. So it's it's very close to closeness centrality because you have a look at short distances to other actors. Okay, so those were not all the measures, but due to the limitations of the time, I'm not going to explain clustering or click analysis here further because it would be too complex. But this is also a very interesting part of social network analysis, that you can examine subgroups in a network. So there are several algorithms by which you can compute which person is in the same cluster with other persons. That's very interesting because if you have maybe a subset of MySpace, you can guess where all those friendship groups are. So you can say, okay, those are the people from one town, or it's I think you can imagine what you can do with these measures. Maybe another time I'm going to hold a talk about this, but not at this point. Okay, then I'm going to show you briefly only 2 algorithms because I picked out 2 which I thought were very basic and very interesting. And there are very many ways of computing things, so there are very many algorithms. And yeah. So algorithms in social network analysis are mostly borrowed from graph theory, and yeah, of course, because a social network is, as I mentioned, a network and a graph. And the trick is to interpret them accordingly. So yeah, social network just gives you a kind of toolbox to interpret all those algorithms you can guess from graph theory. Oh no, not all those, but most of them. And of course, of course, time complexity must also always be considered. So a traveling salesman problem is a traveling salesman problem also in a social network. And yeah. So one very basic is of course Dijkstra algorithm, which computes shortest paths in a network. You need this in very many measures. Like I told you in centrality or prestige, shortest paths are always a very important thing in social network analysis. Yeah, of course, it's a classical algorithm in graph theory. Everybody who has heard of maybe data structures and algorithms has heard of Dijkstra algorithm. And Dijkstra introduced this algorithm in 1959, and it calculates the shortest path between two nodes for positive edge weights. And yeah, it's used for example, calculation of centrality and prestige. Another very important algorithm is the hits algorithm. It's very similar to, with a page rank algorithm, and comes from search engine optimization. And hits algorithm is briefly for hypertext-induced topic selection, or hubs and authorities algorithm by Kleinberg, who introduced this algorithm in 1999. And hits algorithm calculates importance based on links in graph structure. Normally this algorithm was designed to weight nodes in a hypertext context. So if you have hypertext documents as nodes and links to other hypertext documents as edges or links or ties, then you can, by looking at this graph structure, guess how important one of those hypertext or nodes. I've lost my point. You can calculate the importance of those nodes just by the graph structures. Yeah, and with this algorithm, every node gets a hub and an authority value. And a hub value, a big hub value means that this node is linked often by nodes with high authority values, and high authority means that this node links many nodes with a high hub value. It's like I wrote there, it's kind of mutually reinforcing relationship, And if you translate all this to social network analysis, you can say that, that people who have a high hub value are voted very often by people which were voted very often. And if you translate this, I would say vote is the right term to say, that you can say which people vote or are voted. Yeah, and then with this you can compute importance in this network. And this algorithm is not classical, but yet interesting. I myself used it in my master thesis, and sometimes it's just like this. Maybe this is, I don't know, maybe this is not classical social network analysis, but you can, if you add the right interpretation to those algorithms, you can do very fancy things on your social network. Okay, I'm going to explain you briefly something what you can do by enhancing everything with an ontology. Yeah, I'm first going to explain what an ontology is. Yeah. Gruber said in 1993 that an ontology is an explicit specification of a conceptualization which nobody understands, but everybody writes it down. And this is what you cite if you're writing something about ontologies in your maybe scientific paper. It's horrible. And later on, he wrote a better explanation that an ontology defines or specifies the concepts, relationships, and other distinctions that are relevant for modeling a domain. So, yeah, if you want to model a domain from everyday life, then you could do this by specifying an ontology. It's really this abstract as it stands there because you could really model everything as an ontology. Yeah, ontology was first a philosophical term, but was later used in this should mean artificial intelligence, I'm sorry, and knowledge modeling. And today it's one of the basic ideas of semantic web, as Tim Berners-Lee proposed. And the trick is that every ontology can be modeled as a graph or expressed as a graph. So, yeah, why should we use an ontology? For example, ontologies are used in recommender systems, and social network analysis combined with ontology can add a new dimension on bipartite networks. And you see this little network over there. The squares represent actors, and the cubes are kind of affiliations. So we could think of the actors to be attendants of this Congress, and the affiliations maybe talks, as I mentioned before. And now you could go on and say, okay, which talk is in which track? And then you could add another layer to this network by adding a kind of ontology which describes which talk is near to which other talk. So then you don't have only those edges between talks and persons, but also between the talks itself. And then you could say, okay, which person attended which talk together, and which other talks could be interesting for this person because they're very close to the talk the person listened to. And this is a very interesting thing you can do, and it shows how many things you can do by being creative in social network analysis. Yeah. And you could make ontology-based recommendations. It's just this slide. It's also a very big subject. Yeah, by taking an ontology, you can categorize data items, for example. Like I mentioned, you can categorize talks. And you could structure metadata. And if you are a bit into recommender systems, ontologies are also good for, they can overcome the cold start problem of a recommender system. So you don't need to have a start. You don't have to collect data for a recommender system of who is choosing what, because by having an ontology you can say, okay, maybe this book is related to this book on Amazon, and you don't have to look at this who bought also thing at Amazon. And I hope you can imagine. Otherwise you can ask questions later. Okay. So, no. The example, the example was, Hannes asked me if I wanted to analyze Sputnik data this year. And we kind of met and made a kind of model for tracking social events from Sputnik data, but it was a bit more tricky as we thought in before. And I can explain, I can show you the model we made. Like, okay, I can show you the ideas we made, but yeah, the real example will be, we have to compute the real example after the Congress, I guess. So I'm going to give you your website on which you can check later after the Congress if we are finished or not. But I'm very sorry. Okay, so some of you have those little Sputnik tags, and which is tracking who is walking around and who is staying here in this Congress Center. And we thought, okay, we only have the point people is, the location, and how can we make a kind of social event of this? And we have 3 types of social events, which are followed state and talk attendance. And followed means that 2 tags or 2 persons are walking together in the building for, I guess, we have centimeters as values. So the number of meters 2 persons walk together is collected this year, and we thought this would be a good indicator for showing who is friend with whom, because friends tend to walk around in the building more often than people who are not connected. Then, state means who is staying how long with whom at which location. So maybe you are all friends now because you're all attending my talk. No. Maybe if you go together for having lunch or stuff, you're staying 1 hour together at the lunch area. So, yeah. We don't know how high error rate is. We thought, okay, let's just track those types of social events into a database and sort out later which kinds, what will happen if we analyze it. Okay, I forgot the 3rd one. It's talk attendance. So, but I guess this didn't work properly this year. So maybe next year. So we thought that it would be interesting to know which persons are attending the same talks. So maybe we could also make recommendations like, okay, people who were also attending this talk also attended those talks and could make some kinds of recommendations. Yeah, okay, as I mentioned, those data was additionally generated this year. So maybe afterwards we have kind of database dumps to analyze for everybody. Yeah, the tool we wrote already calculates some measures, and they are a degree and between centrality for nodes, and a kind of normalized followed value, a normalized state value for edges, which means that, the followed values, for followed values, we incrementally, we summed all the following values between 2 actors to a big, kind of bunch of centimeters. The persons walk together on this Congress, and the state value is the time 2 persons spent together in our model at this Congress, and we kind of normalized it, so the values are also divided by the highest value a relation has. And there are also simultaneously attended talks at the edges, and kind of friendship factor, which is not implemented yet. And it's, as I said, it's not yet finished. This is kind of, it's very blurry, I'm sorry. It's, the point was the tool is finished and the data is collected, but the tuning would take 50% of the time we already invested into this project, because this is dot output from the graphics package, and I wrote this dot output, and then I said, okay, I make those edges with a higher value thicker and stuff, but I didn't have enough time on this Congress to tune it. So yeah, I'm going to do this afterwards. Okay. I was faster than I expected. So those are the list of references. This is the list of references. I used the big book Social Network Analysis by Wasserman and Faust. It's kind of, for me, it's kind of Bible of social network analysis. It's very detailed. So if you really want to get the whole big thing, you should have a look at social network analysis. And there's also a German title. It's Einführung in die Netzwerkanalyse, Grundlagen, Methoden und Forschungsbeispiele by Jansen, which is in German. But it's more simple. And she's a social science researcher. And by reading this book as a mathematician, you would say, oh my God, all the formulas, oh my God, I have to buy Wasserman and Faust. So, and another thing, I looked up all the algorithms in Wikipedia. So, thank you for attending my talk. If you have further questions, please write at my email address. I'd be happy to hear from you, or visit my blog. And I think when we've made all this Sputnik analyzation, you can read it in my blog. Okay, thank you. Okay, if you have questions, just ask.
Hi there. Thanks for the talk.
Hi.
I had one question because I don't know, you mentioned that you couldn't get talk attendance from the Sputnik data, and just because that seems like something that would be kind of obvious and easy, maybe it's interesting why there isn't that information.
Hannes did this part of the program. He's not here at the moment, but I think it's not that easy. You only have those readers, which are at one point, and I think it's very hard to get a very exact location where a person is. And I think it's related to this problem.
You gave a talk on it.
Yes? Okay. I didn't attend this talk. I was analyzing data, which went wrong. Over here.
The title of your talk was I Know Who You Clicked Last Summer. Do you think that network analysis could be a threat to members of social networks on the internet, that they are analyzed by strangers and strangers find out about their data and their relations?
Of course, because if you have the whole network, you can make those structure analysis. And I would not say that every stranger could analyze this whole network, because you have to get the data. So what I did once before was parsing a whole network by from the website, which is, I guess, illegal, I don't know, or very much effort. But who is analyzing this data for sure is the company behind every network site, because they have all the data and all the data models in a nice database, and they will do network analysis for sure. And more network analysis than you will see in your own profile in your Web 2.0 community.
To your right. So about
Hi.
your question, I work at Last.fm, and we know from
okay.
experience that people are scraping our pages a lot. So I would assume as soon as you put something on a public website, lots of people will analyze it. My question was related to the graph you showed. I was just curious, could you maybe give us a hint towards your interpretation of that graph? For example, do you already know specific nodes in that graph?
You mean from the Sputnik data?
Yeah, there was a very central node. Is that maybe something stationary that was at a very prominent spot?
Well,
or do you know anything about that graph?
At this point, I really don't want to say anything about this, because I was very incontinent. It was not. The analyzation is not as good as I wanted it to have, and I couldn't guess anything from those measures, and I really want to tune it before I say anything about which node is central or not, because those Sputnik tags are worn by people in here, and it's really a brand hot topic we're doing here, because we also wanted to show members from our community what social network analysis could do. And I don't want to say anything about this network until it's tuned, so I'm content of it. Okay. Dahin. Maybe with a microphone, so I don't have to repeat it if it's long.
Okay, it would be interesting to analyze networks where you don't know the owner, just looking from the outside, like maybe Xing or LinkedIn or Orkut or some of those systems. Are there any tools, or have you been looking into analyzing those systems?
By tools?
Yeah, by probably scanning through the users and seeing which information you can get from the outside.
I haven't done this before. Have I done this before? Yes, but I won't say in the community. Yes, you can do this, but the tricky point is to get the data. You have to decide for a kind of package you want to use for network analyzation, programming language and stuff, and then you have to get the data. Some communities offer web services, but in other communities, which are, you have to really write a parser or stuff to collect the data. And it's not this easy, and mostly combined with a lot of effort you have to put in it. But it's yet very interesting. Okay. What? Okay.
If he has a MySQL dump from some community, anonymize it and publish it. I think it would be really interesting.
Yeah, there was a StudiVZ dump somewhere the last year. So if somebody would give me a StudiVZ dump in maybe I can analyze it by social network analysis. Would be no problem.
Hello.
Hi.
Can you say something about the analysis that you have been doing on the Sputnik data so far in terms of what methods and tools you're using? I mean, you obviously, when you just throw dot at all this data set, you get a gigantic graph that's just a big mess. But where do you go from there? How do you look for structure?
Hannes was hacking on Sputnik in Dylan, which I cannot program in. So Hannes was hacking all his parts in Dylan, and I myself can, I can program in Java. So we made a kind of plan for MySQL databases, and I said, okay, I'm going to do the analysis in Java. And there's a quite nice Java package, which is called Jung, J-U-N-G. It's a Java Universal Graph Framework, and it has already implemented some of the measures I showed you before. But there are also some pages which collect tools or frameworks for analyzing social network analysis, and I can write it down and maybe put some of. Okay, I cannot write it down. Okay, I'm going to remember. I'm sorry. So I'm going to put this on my blog, and then you can, look if there's also a social network analysis package in your favorite programming language, maybe. Okay.
Can I? Okay. Sorry, I've got a more. Can you hear me? Okay.
Yes.
I've got a more theoretical question. In the examples you gave, there were more actors than items. I mean, for example, you analyze friendship. But what happens if you analyze few actors and many items? For example, when you go to Walmart and buy some things, and you've got many items in your basket, and check out. What happens with the methods you mentioned in this case?
Well, I would just flip, because the things you want to examine are, I guess, the things from the basket. And then I would just say, okay, the actors in this case are the things in your basket, and the affiliations are the customers who are buying it. So you can just flip it, and then you have the right point. So, okay, always depends on what you want to, I don't know. I guess it's no problem in which way you do it. I don't know. Maybe there are some problems, but I don't know them. Okay. Further questions?
Yeah,
Hi.
you've been talking about analyzing static snapshots of social networks.
Yeah.
How about analyzing some patterns or trends that occur when you look at a social network, spanning from time 0 to now, for example, Sputnik data? How do maybe friendships or contacts evolve? Because for static networks, there are a lot of types of ways you can visualize this, and it's generally a beaten path. You have your methods and stuff, but I don't know exactly about this dynamic approach.
Okay, so yeah, the classical approach is for sure take a model, a static social network, and in my opinion, adding this time dimension is very, very difficult. And I was working a long time for Information Science Institute at university, and there were several theses about this problem with adding a kind of time component to a network. And maybe if you're really interested in this topic, I would suggest you for reading or searching for scientific papers on this topic. But yeah, I cannot really say something about that, but because in my opinion it's very difficult, and what you could do is take out several slices in time of a social network and then somehow compare it, but I couldn't tell you in which way you should compare those slices. So be creative and have fun and just do something. Okay. Yeah, some more questions? So, okay. If somebody has another question, could write me an email.
Could I just quickly ask a follow-up to that one? You mentioned searching for papers on what he just asked about.
Yeah.
Do you have any idea of the terminology this would be used to refer to this? This idea of it was dynamic social network analysis enough, or?
Which term?
For looking at the progression of a social network over time, would just be like because you have more information about this field, what would be the words we'd look for if looking for this?
I don't know. I have never been searching for social papers in this way, for papers in this way before.
Okay, thanks.
Okay, I'm sorry. Okay. Thank you.